Okay, boys and girls, today we're going to continue working on division of fractions, and today we're going to be combining the two skills that we learned on the past two lessons. So we're going to be combining dividing unit fractions by whole numbers and also dividing whole numbers by unit fractions. For the lesson today, though, you're going to be needing a pair of scissors. Make sure you grab one. You're going to be needing a glue stick. Make sure you grab one of those. And you're going to be needing a sheet of paper like this one. Make sure you also have one of those. So make sure you have those three things before we get started. And once you have all these three things, go ahead and pause the video and cut this sheet out. Cut it out into each little square. So go ahead and do that now. Okay, now here are mine all nice and cut, and I'm not going to be needing the glue and the scissors now for a while, so I'm just going to put those off to one side, and now we can go ahead and get started. I'm also going to put my little cutouts here off to one side because I'm going to need them in just a little bit. Okay, to start off our notes, because we're going to be talking about the two types of problems we work with, what I want you to do now is I want you to split up your page into a nice T-chart, because on this side, we're going to be working with the problems that have the whole number first. This type of problem is called whole number divided by unit fraction. So here's the whole numbers first. And then on the other side, we're going to be working with the problems that have the unit fraction first. Okay, so all the steps are exactly the same, boys and girls, as we talked about on the last lesson. The standard algorithm steps are the same, keep, change, flip. What's slightly different is what the picture looks like. And the reason for that is because each type of fraction has a different amount that you start off with. So let me go ahead and give you a problem so you can see what I'm talking about. Let me give you on this one, because the whole number is first, I'm going to use the whole number 2. And I'm going to divide it by a unit fraction such as 1/7. Then what I get is obviously the quotient, but I'm just going to leave it blank for now. On this side, the side where the unit fraction is first, I'm going to write the 1/7 first. And that is going to be divided by 2. Now for both of these, standard algorithm is the same. The way you solve them using math is going to be exactly the same. So I want you to go ahead and do that. Now you can pause the video and do it on your own and then play the video to check if you did it right, or you can just follow along with me. So let me go ahead and to solve this problem, that 2 needs to become a fraction because all numbers must be fractions. So it's going to be 2 wholes divided by 1/7. And then I'm going to do keep, change, flip. I'm going to keep the first one. Division is going to change to multiplication, and I'm going to flip my second fraction. The 7 goes up, the 1 comes down. 2 times 7 is 14. 1 times 1 is 1, and this is an imaginary 1. The 14 becomes my final answer. On the other side, using standard algorithm, the 2 needs to become a fraction because it's currently a whole number and we can't work with whole numbers. So I'm going to rewrite it over here, over 1 divided by 1/7. And then I'm going to do keep, change, flip. The 1/7 stays a 1/7. Division changes to multiplication. I'm going to flip my second fraction. The 1 is going to go up. The 2 is going to come down. 1 times 1 is 1. 7 times 2 is 14. Now if you notice, this one has a 1 and a 14. This one also has a 1 and a 14. But where they're located is different, making the answer completely different. Here our answer is 14. On this side our answer is 1. 14th. Now I want you to look at how both of these problems started out. This one starts out with a whole number. This one starts out with a fraction. The quotient for this one is a whole number. The quotient for that one is a fraction. I wonder if that is a coincidence. Go ahead and look in your cards. Find the ones that say quotient. This one goes on this side. And that one goes on that side. And for now, we're not going to glue anything. We're just going to go ahead and leave it like that. And we'll glue at the very end. Now let's go ahead and see how these two problems would look in a word problem. Now to consider that, what we have to do when we look at this type of problem is we need to ask ourselves, when you're working with a word problem, you always ask yourself, what does blank have? And this blank just goes with whoever the word problem is about. For example, like this one right here. The word problem is about Jessica's mom. So as you're reading this word problem, you have to ask yourself, what does Jessica's mom have? And if you can answer this question, you're going to be able to know whether the whole number goes first or the fraction goes first. So let's go ahead and read this one. It says, Jessica's mom baked a chocolate cake for dinner. After her family ate their dessert, there was 1/7 of the cake remaining. Jessica invited her 2 friends over to share evenly the remaining cake. If each of her friends received the same portion of cake, how much did each person get? Okay, so they're sharing something. Think about what it is that they're sharing, those 2 friends. And what it is that they're sharing is what Jessica's mom has. She has blank amount of cake that the kids or the friends can share. What does Jessica's mom have? She has 1/7 of the cake. So here on this side, what I have is 2 wholes. On this side, what I have is 1/7. So I want you to consider that, and let's look at the other word problem. Let's go ahead and find it in our little stack. Here's the other one. It says Jaime has been planning for Christmas. He went to Walmart to purchase 2 rows of wrapping paper. He will cut each row into equal pieces of 1/7 to wrap all of his gifts. How many gifts can he wrap with 2 rows of paper? Okay, so Jaime is wrapping gifts. And to wrap those gifts, what does he have? He has wrapping paper. And how much of it does he have? He has 2 whole rows. So in this problem, what does Jaime have? He has 2 whole rows. In this problem, what does Jessica's mom have? She has 1/7 of a cake. So when you are looking at a problem, what we have is first, if you remember from our notes from yesterday and the day before, have. And now go ahead and decide where each word problem goes. Does Jaime and his 2 rows, what he has is 2, does that go on this side or this side? And Jessica's mom, who has 1/7 of a cake, does that go on this side or this side? If you said that Jaime and his 2 rows of paper goes on this side, you're right. And if you said that Jessica's mom and her 1/7 of a cake goes on this side, you're also right. Now we have to consider how to look at the pictorial models, which are these. That's one of the pictorial models, and here's the other one. Here on this one, what do we have? We have 2 holes being split up into 7 pieces. And on this one, we have 1 hole split up into 1, 2, 3, 4, 5, 6, 7 rows, and one of them is shaded. So here we have 2 holes. Here we have 1/7. So go ahead and think about that and consider that here we have 1/7 and here we have 2 holes, and decide where each of these goes. If you said that the pictorial model with the 2 holes goes with the 2 divided by 1/7, you're right. And if you said that the pictorial model with the shaded part, with the 1/7 shaded, that is being split up into 2 pieces, goes on this side, you're also correct. Now let's go ahead and look finally at these 2 number line models. We have one number line that has 0, 1, 2, and here we have a number line that has 1 hole being split up into 1, 2, 3, 4, 5, 6, 7, and we have one of those shaded, or you can also think about it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14ths, and one of those pieces is worth 1/14. So the answer, the quotient, also kind of helps you with these models. Now that I've talked about the 2 models, this one representing 2 holes and this one representing 1/7, and then considering that here what I have is 2 and here what I have is 1/7, where would you place these number lines? If you said that this number line, the one with the 2 holes, goes on this side, and that this number line, the one with the 1/7 shaded, goes on this side, you're correct. Now I want you to look at those. Look at the column of the whole number. Look at the column of the unit fraction. Notice some similarities and some differences. Look at the pictorial model and look at that pictorial model. What do you notice about the one that starts with the 1/7, the one that starts with the unit fraction? These are always going to have something shaded. These don't, because they're being split up into smaller pieces. What do you notice about the number line models? Again, the unit fraction model has a piece shaded. What do you notice about the unit fraction and its answer, its quotient? Every time you start with a unit fraction, your answer is always going to be a unit fraction or a fraction. Every time that you start with a fraction, your answer is a fraction. Every time you start with a whole number, your answer is going to be a whole number. So those are some things that you need to keep in mind on the handout that you're going to be working on in just a minute. Now what I want you to do is I want you to pause the video and go ahead and glue down all of these little cards, all of these little pieces of paper that go with each side. Go ahead and glue those down and pause the video. Okay, boys and girls, now that all of that is nice and glued, we can go ahead and look at our independent practice, which is this one right here. Make sure that you get one. And we'll do number 1 together. It says, which division problem is shown by the model below? What do you have? And I want for you that on each and every one of these problems, I want you to write that. What do I have? Question mark. What do we have? Do we have 1/8? 1/4? Do you have 4 wholes? Do you have 1/6? We can automatically eliminate one of these answers because we do not definitely have 4 wholes. We have 1 whole, and if you see this dark lines here, it's being split up into 4s. And my answer to this question is right here. It's the little shaded part. How much is shaded? 1 out of 12. 1/12 is the answer that eliminates this one and this one, making my final answer B. Now again, I want you to, on every problem, consider, what do I have? Miss Lucio has 1/3 of a casserole. What does she have? What I have goes first. Go ahead and continue this handout on your own, boys and girls. And on every single problem, ask yourself, what do they have? And what do they have goes first. And that's going to help you find the answer to all of these problems. Go ahead and get started, boys and girls.